Hi there, this is Dr. C. Sonia, Assistant Professor in Chemistry, SNS College of Technology. Today in this video, we will explore about the saturated calomel electrode. The saturated calomel electrode is a secondary reference electrode. We've already explored about the primary reference electrode. So to overcome the limitation of saturated hydrogen electrode, the saturated calomel electrode is developed. This is called the secondary reference electrode. It consists of a glass tube. Pure mercury is placed at the bottom of the tube and is covered with a paste of mercurous chloride. The term calomel, it comes from the mercurous chloride that we use in this electrode. The remaining portion of the tube is filled with the saturated KCl solution. The bottom of the tube is sealed with the platinum wire. So the saturated name for this calomel electrode, it came from the saturated KCl solution that we use. So the calomel electrode is represented by the equation Hg in the liquid form, then Hg2Cl2 solid and KCl saturated solution. So to understand the learner's perspective, recognize that the students may find electrodes abstract, especially the interplay of the mercury and the mercurous chloride chemistry. Connect with their possible difficulties visualizing the electrode's construction and why it is a stable reference. So why use a different reference electrode than the standard hydrogen electrode? So define to clarify the core concept to teach. The calomel electrode is a reference electrode based on the redox equilibrium between the mercury and the mercurous chloride in a potassium chloride solution. Its potential depends on the chloride ion activity, making it stable and reproducible. How can we use a practical reference electrode? Explain the calomel electrode construction. If you're going to explore into this, deep into this, you'll find the solution. So the saturated calomel electrode, if it acts as an anode, the reaction is the mercury Hg in the liquid form, it loses electron to give Hg2 plus 2 electron. So the anode, always the oxidation reaction will take place. And when it combines with the chloride ions that is present in the solution, it gives Hg2Cl2, mercurous chloride. So the net reaction is mercury plus chloride ion to give Hg2Cl2 plus 2 electron. Mercury undergoes oxidation to produce mercurous chloride and combines with the chloride ion to give the mercurous chloride. The concentration of the chloride ion is decreased in this process. Calomel electrode, the electrode acts as a cathode. If this calomel saturated reference electrode acts as a cathode, the reactions involved are 2Hg2Cl2 gives Hg2 plus 2Cl minus. So the cathode, the reaction is always the reduction reaction. So Hg2 plus it takes up 2 electrons to give 2 HgCl. The net reaction is the mercurous chloride plus 2 electrons, it gives Hg plus 2Cl minus. The mercurous ion present in the mercurous chloride undergo the reduction to give mercury. Hence, the concentration of the chloride ion is increased in this case. So when the electrode acts as an anode, the chloride ion decreases, and when the electrode acts as a cathode, the chloride ion is increased in the solution. So you have to imagine the calomel electrode has a constant benchmark or the yardstick for the measuring the electric potential, like having a standard weight to compare other weights. Visualize the construction. Mercury at the bottom covered by a paste of mercury and mercurous chloride surrounded by saturated KCl. So this is the ideation that is being done. Show how the electrode interacts with the external solution through a porous wick. So there are certain characteristics of calomel electrode. The electrode potential of the calomel electrode depends upon the activity of the chloride ion. When the concentration of the chloride ion decreases, the electrode potential of the calomel electrode increases. That is when it acts as an anode. The single electrode potential of the calomel electrode with various concentration of KCl on the hydrogen scale at 298 Kelvin are given below. So when we use a 0.1 N KCl solution, its value, the electrode potential value of the Calomel electrode is 0.3338 volt. When you use 1 N KCl solution, it varies, that is 0.2800 volt. For a saturated calomel electrode, the electrode potential is 0.2422 volt. The potential of the calomel electrode is temperature dependent.